At exactly 0447 a.m. on March 15, 1943, a mechanical titan emerged from the womb of Building 1 in Renton, Washington. The first B-29 Superfortress rolled off the assembly line, its polished aluminum skin reflecting the gray, weeping sky of the Pacific Northwest. There were no marching bands, no champagne bottles shattered against its nose, and no speeches from politicians. The only sounds were the soft hiss of the rain and the rhythmic cooling of thousands of fresh rivets. 7,200 workers stood in the damp air, their faces etched with a mixture of exhaustion and awe. They were looking at a machine that didn't just fly, it commanded the atmosphere. The world was burning, and the United States was losing the race against distance. American bombers like the B-17 were legends, but they were tethered to their bases. They couldn't reach the heart of the Japanese Empire. General Henry Hap Arnold, a man who viewed time as a weapon, demanded a miracle. He wanted a pressurized fortress that could fly 3,500 miles and carry 10,000 pounds of fire to altitudes where enemy interceptors were nothing but ghosts. Engineers told him it would take 5 years. Arnold, with the weight of the Pacific War on his shoulders, gave them 18 months. The result was the B-29, the most expensive and complex engineering project of World War II, surpassing even the Manhattan Project in its initial cost. It featured remote-controlled gun turrets and 4 monstrous Wright R-3350 engines, each a 2,200 horsepower furnace. But to build this dream, Boeing needed more than engineers. They needed a factory that didn't exist yet. They chose Renton, a quiet town that would soon be swallowed by the longest assembly line ever constructed. As that first bomber moved forward on its wheels, the workers knew only one thing. The sun would set on 5 more completed aircraft today. The war was hungry, and they were the only ones who could feed it. The Renton plant was not merely a factory. It was a sprawling, self-contained city enclosed within a single, cavernous roof. Stretching 1,200 feet in length and covering more than 1 million square feet of floor space, it was a cathedral of industry. Inside, the air hummed with a permanent electric tension. The production line moved with the relentless logic of a river, starting from the western edge where raw aluminum sheets were shaped into tail sections, flowing eastward toward the final inspection bays where completed Titans stood ready for the sky. This city never slept. It operated 24 hours a day, divided into 3 grueling 8-hour shifts that bled into one another. At the height of the war, the pace was soul-crushing. A brand new B-29 emerged every 96 minutes. From the first rivet to the final engine test, it took only 16 days to transform raw metal into a 30-ton weapon of war. 5 bombers a day, 35 a week. Every station was a synchronized gear in a massive machine. The eastern edge of the plant opened directly onto an airfield, where the fresh scent of Cedar River water met the acrid smell of aviation fuel as finished bombers were towed out for their maiden flights. Every single aircraft had to be perfect. In this city of steel, a loose bolt wasn't just a mistake. It was a potential disaster waiting to happen over the Pacific. The people who manned this industrial city were not soldiers, but they fought a war of precision. Before Pearl Harbor, most had never touched a pneumatic tool. The workforce was a patchwork of American life: housewives, schoolteachers, farmhands, and teenagers who lied about their age just to get past the gate. The average age was only 23. Among them was Margaret Hastings, a 34-year-old former teacher from Spokane. In 1943, she traded her chalkboard for a rivet gun. Her husband was thousands of miles away, building bridges with the Army Corps of Engineers in the Philippines. She wasn't just working for a paycheck, she was working to bring him home. Margaret's world was the tail section of the B-29, a cramped, metallic labyrinth. Every morning, after leaving her sons with her mother at 5 a.m., she would spend 12 hours squeezed inside the fuselage. She had to crawl through hatches barely 18 inches wide, navigating a maze of structural ribs and control cables. Her job was to connect hundreds of color-coded wires to terminal blocks she could often only reach by feel. The cotton gloves provided to protect her hands were too thick for such delicate work, so she cast them aside. By the end of every shift, her fingers were a map of raw cuts and silver aluminum slivers. She never complained. She knew that if one wire was crossed or one connection was weak, her husband's life and the lives of 11 other men could vanish in a flash of fire. If Margaret Hastings was the nervous system of the B-29, then James Patterson was its muscle. At 19, Patterson was a farmhand from eastern Washington who had traded repairing tractors for the most dangerous plumbing job in the world: the B-29's hydraulic systems. These lines controlled everything from the massive landing gear to the bomb bay doors. Under 3,000 pounds of pressure per square inch, hydraulic fluid was no longer a liquid. It was a scalpel. A pinhole leak could slice through human bone like a hot wire through butter. Patterson lived by a single, unyielding commandment. His instructor had told him, "Tighten every fitting until you feel resistance. Then turn it exactly 1/4 turn more. Not half a turn, not 3/8. Exactly 1/4. For 2 years, Patterson became an obsessive guardian of that quarter turn. He carried a torque wrench that he calibrated every Monday morning with the devotion of a priest. His coworkers teased him, calling him Quarter-Turn Patterson. But he never smiled back. He knew that if a fitting failed over Tokyo, a pilot would be left with a dead cockpit and a one-way ticket to the Pacific. In his locker, he kept a crumpled letter from a pilot who had survived flak damage because his landing gear deployed perfectly. Whether Patterson had worked on that specific plane didn't matter. To him, every aircraft was a promise that he refused to break. The B-29 was a mosaic of 600,000 individual rivets, and every single one was a heartbeat of the factory. To the outside world, Renton was a miracle of statistics, but inside, it was a sanctuary of memory. Every week, the mailroom received letters from the front lines, not addressed to generals, but to the riveters of Line 7, or the electricians of Station 4. These letters were pinned to bulletin boards near the break rooms, their edges curled by the humidity of the plant. The workers would read them in silence during their brief lunch breaks. Some letters spoke of narrow escapes through curtains of fire. Others simply said, "She brought us home." No one cheered after reading them. They would fold the letters, finish their coffee, and walk back to the assembly line a little faster than before. There were no second chances in Renton. A single missing cotter pin or a misaligned fuel line could result in 10 men detonating inside their own bomb bay before they even saw the target. The pace was relentless, but it wasn't driven by the managers in their ties. It was driven by the ghosts of the letters on the board. They weren't building machines to kill. They were building shields to protect. Every time a rivet gun hammered, It was a pulse of hope that the boy who sat in that cockpit 6 weeks from now would walk off the tarmac alive. The B-29 was a masterpiece, but it had a heart made of fire. The Wright R-3350 engines were the most powerful radials ever built, but they were notoriously unstable. Pilots called them the engines from hell. Because of their compact design, they overheated within minutes of takeoff. Oil fires were common, and many crews died before they ever reached Japan. Their bombers transformed into falling torches over the Pacific. Boeing engineers modified the cowlings 7 times, but the engines kept failing. The solution didn't come from a laboratory, it came from Robert Chen, a second-generation Chinese-American mechanic at Station 6. Chen was obsessive. He kept a secret notebook, tracking every engine serial number and every failure report. After 6 months, he found a terrifying pattern. Engines installed on Fridays failed 60% more often than those installed on Tuesdays. The culprit was a tiny brass washer in the oil pressure regulator, worth only 11 cents. The washer had a slightly beveled edge on one side. If installed backward, a common mistake for exhausted workers on a Friday evening, it starved the cylinders of oil. Chen bypassed the chain of command, risking his job to write directly to the chief engineer. His bravery led to Technical Directive 29447. 1,400 engines were re-inspected, and the failure rate plummeted. Robert Chen never received a medal, but thousands of men lived because he refused to stop asking why. By mid-1944, Renton was winning the war of production, but the military was losing the war of human capacity. A B-29 required a crew of 11 highly trained specialists. It was a flying computer, and the Army Air Forces couldn't train men fast enough to fly them. This created a tragic bottleneck. To meet the demand, training was accelerated and standards were lowered. The first combat missions launched from India and China, Operation Matterhorn, were a catastrophe. Of the 98 bombers dispatched in the first raid, nearly a quarter were lost to mechanical failure and fuel exhaustion before even seeing the enemy. The problem wasn't the machine, it was the impossible geography of the Pacific. Flying over the hump of the Himalayas stretched the B-29 beyond its design limits. In late 1944, the strategy shifted. The bombers moved to the Mariana Islands, Saipan, Tinian, and Guam. From these bases, Tokyo was within reach, but the mission profile changed from high-altitude precision to low-altitude night incendiary raids. The workers at Renton were never told about this shift. They didn't know their precision-built fortresses were now being used as giant torches to burn cities made of wood and paper. They were only told to build them faster as the Pacific War began to consume both metal and men at an insatiable rate. While the workers at Renton focused on the relentless rhythm of 5 bombers a day, a shadow was moving within their ranks. A secret project, code-named Silverplate, required 15 B-29s to be plucked from the assembly line and sent to a classified facility in Omaha. These were not ordinary bombers. They were the elite of the fleet, modified beyond recognition. Every ounce of unnecessary weight was stripped away, including all defensive gun turrets except for the tail guns. The bomb bays were reinforced with massive steel supports to carry a single gargantuan weapon. The workers who installed the rivets and wires on these specific planes were told nothing. They saw the unusual specifications, the missing turrets, and the strange fuel configurations. But they asked no questions. Silence was a patriotic duty. Among these aircraft was tail number 44-86-292, a plane that would later be named Enola Gay. The hands that built it, perhaps the hands of Margaret Hastings or James Patterson, were the same hands that built thousands of others. They performed their work with the same cold precision, unaware that they were preparing the delivery vehicle for the end of the world. The silverplate B-29s were ghosts in the factory, mechanical harbingers of an age no one was ready for. At 08:15 a.m. on August 6, 1945, the precision of Renton met the reality of the atomic age. From 31,000 feet, the Enola Gay released Little Boy. For 43 seconds, the world held its breath. When the sky over Hiroshima turned a blinding, impossible white, the shock wave reached the bomber 11 miles away, shaking the airframe built by the women in Washington State. Inside the cockpit, co-pilot Robert Lewis stared at the rising mushroom cloud and wrote 4 words that would echo through history. "My God, what have we done?" In an instant, 70,000 lives vanished. 3 days later, the boxcar struggled toward Nagasaki. It was a mission plagued by mechanical failure, a malfunctioning fuel pump that rendered 600 gallons of fuel unreachable. Major Charles Sweeney pushed the aircraft to its limits, desperate to find a gap in the clouds. When the Fat Man detonated, it was more powerful than Hiroshima, but the hills of Nagasaki contained the blast. Boxcar returned with its fuel gauges reading empty, firing flares as it sputtered onto an emergency runway in Okinawa. The war was over. The workers in Renton heard the news over the plant's loudspeakers. They stopped their hammers. They stopped their drills. For 11 minutes, 5,000 people stood in a silence so heavy it felt like lead. They had built the machines that ended the war, but at a cost that none of them could truly calculate. On May 28, 1946, at exactly 11:47 p.m., the rhythmic thunder of Renton finally faded into silence. The last B-29 rolled off the line, but there were no cameras this time, no speeches. The war was over, and the world was trying to forget the fire. The aircraft was flown to a desert depot in Arizona, sat in the sun for 3 years, and was eventually scrapped for parts. The workers, the Margarets, the Jameses, the Roberts, clocked out for the last time, walked to their cars through the familiar Washington rain, and disappeared back into civilian life. Today, the Renton plant still stands. It no longer builds fortresses. It builds Boeing 737s at a rate of 40 per month. The technology has changed, the rivets are driven by robots, and the purpose is travel, not terror. Yet, if you know where to look, the history is still written into the bones of the building. You can see the faded paint markings on the concrete floors that once marked the boundaries of Station 8. You can see the old rivet holes in the support beams where the scaffolding of the B-29 once stood. These are the scars of a generation caught in the machinery of history. The question that lingers over Renton is not one of military strategy, but of human conscience. What do we owe to those who build the machines that change the world? The workers at Renton didn't choose the missions. They didn't choose the targets. They only chose to do their work with a precision that became a moral obligation. They believed that by building the best machine possible, they were saving lives. Both things are true. Their work ended the war, and their work took hundreds of thousands of lives. They are inseparable truths written in the aluminum skin of every bomber that ever flew into the sun. The plant remains a monument not to triumph, but to the weight of our hands and the consequences of the things we choose to build.